In this video, we are going to go through the steps on how to properly identify a sedimentary rock. As a warning, this video may be more educational than it is entertaining. So in front of you, we can see the table that you will find in your learning management system that should correspond with the specimens in your rock and mineral kit for sedimentary rocks. As always, I'm going to have my lovely assistant help fill in this chart, which at this point in the semester, you hopefully appreciate her nice handwriting. If it was mine, we would not be doing so well. So let's get started. We're going to work through specimen 27. Okay. Here, just to give you a couple different examples. These are both 27s. Okay. First thing I want to figure out is the composition. Now, if you need a refresher on composition, textures, or depositional environments, I encourage you to go back and review the sedimentary properties video on my YouTube channel. Now, to start with composition, remember back we want to know, is it detrital or chemical? Was the specimens contain particles that are from other pieces and transported, or do they form in place? Well, if you remember from the videos, an easy check again is using that same acid, what we find in vinegar, that weak acid we can get from any hardware store. And unlike some of my other videos, not very exciting. It is simply just soaking into the pore spaces that make up this rock here. So what that tells us is that most likely this is not a chemical rock. This is a detrital specimen. So in our composition, we would say detrital for number 27. All right. Now, if it's grains like this, sands, or conglomerates where we can identify a couple of the minerals that are in there, that's what we need to work on. So again, a hand lens, mine looks a little different than what would be in any of your kits. Again, trying to identify, see if I can see any of the faces, can I see cleavage, can I see fracture? Revisiting any of the mineral properties that we looked at during our mineral identification or the mineral properties videos. Now, to help you out with this specimen here, this mainly contains a fair amount of feldspars with some quartz. So under this, in our composition, we would write feldspar and quartz, just to give us an idea of what's in the composition. Now, while my assistant writes that, I want to make one note of something here. These were grains that we could see. If you cannot see the grains, so essentially anything that is smaller than sand sized, you really cannot see the grains. With that being said, you should not be able to identify any minerals. You might be able to take a guess, but that's not science. So if it is smaller than sand sized particles, you're only telling me if it's detrital or chemical. If it is sand sized particles and larger, you should be able to identify at least one of the main minerals that is in your specimens. Now, on to textures or other distinctive properties. In this one here, okay, we're going to start off with looking at our textures. So again, here is a copy of one of our textures of sedimentary rocks. Again, this can be found on our learning management system. And if we want, we can look at stuff here and we can see that we have our roundness, okay, and our sorting. Again, to give you an idea of what we are looking at. Over on this side here, this helps us figure out sizes. So sometimes the best way, especially if we can see the particles, okay, is we can come over and look at, say, well, these grains are too small for this one here. That seems about right for those size grains. The grains in my rock here are a little bit bigger than those. So if I'm too small for this one, too large for that one, well, I know that one of my distinctive properties is I am sand sized. So in my chart, under textural properties, I would write sand sized grains as my dominant grain type. So now I understand you can't see the grains very well, so you will have to trust me, okay, but go through the steps, look through your hand lenses and try to figure out what is the roundness of your specimens. In this one here, the grains range between subangular and subrounded. So subangular grains and subrounded grains. So for my roundness, I would put subangular to subrounded. And then last but not least, let's try to determine our arrangement, our sorting. Okay, we don't have very many sizes in this our specimen, so it's not that one. Even here, everything looks pretty similar. So I would actually call number 27, this specimen here, well sorted, since everything is approximately the same size. Now, let's take a look at this chart here. And again, kind of like some of our other charts, we can see that this can get kind of busy. It seems relatively complicated, but as a sedimentary geologist myself, I can tell you we're just trying to make it look extra tough. It's not that tough. And the reason is, let's go back to our composition. If we know if it's detrital or chemical, we can automatically get rid of a bunch of the categories. So we determine this is detrital, okay? Things that come from other rocks, other grains. When we come over to this side here, we see detrital. We are on this side, we can see this detrital. Okay? That means, and if I draw a line across here, everything in these categories, these possible categories in the bottom 2/3 are no longer available to select from. So you've limited it to this aspect here. Now, next category we went to, okay? Our texture, we determined sand sized. So if we come down to our area here, we can see that here we have very large grains that are angular, very large grains that are rounded to subrounded. If we come down here, we can see that we are mostly sand sized grains. We already said that our grains are bigger than silt, and they're definitely bigger than muds and clays. So we can now eliminate even more possible categories. Now, if we come across to our large category for our rock name, okay, again, these are the various subtypes. I'm only worried about our choices here at the end here. Sandstone. So if we come across based off of our sizes of our detrital rocks, this would be a sandstone. Now, with that being said, one quick note, I only worry about sandstones, okay? We're not going to worry about breaking them any further. All of the other rocks are distinct enough that you can identify them down to their more discrete categories. But for sandstones, we're just going to worry about sandstone. Now, our last area here is what depositional environment was it deposited in or possibly deposited in? Well, if we look at another chart, again, that will be on our learning management system, we can go through, we can see we've got various different categories. We see biochemical and chemical and biochemical. Okay. Again, those are no longer options. We said this rock was detrital. So if it's detrital, I come to here. Here is sandstones. And I come up and I am looking at possibly that environment, and continue my arrows, or this environment. And again, because I am kind and because I am so merciful, I'm only going to require you to pick one of the environments, okay? You only need to list one environment. And because I like river systems so much, we're going to assume that this came from a stream sand. And that, folks, is how you identify the most awesome category of rocks, sedimentary rocks.